So lesson number 6 just looks at problem solving and trying to determine from a question whether or not you would be looking at a permutation type question or a combination type question. Because that tends to be the more difficult thing to determine is what am I looking for, permutations or combinations, because their formulas are a bit different. So if we recall from earlier lessons, a lot of the times we can actually use the fundamental counting principle or factorial notation to answer questions. Then we have the number of permutations are from n, or permutations that have repetitions would be n factorial divided by a factorial, b factorial, c factorial. That's accounting for the repetitions. Then the number of combinations of r from n. So, class example number 1. How many arrangements of the words poppies can be made under each of the following conditions? So if there were no restrictions at all, how many different arrangements could I make? So how many choices do I have for the first spot? Then, so that becomes 7 factorial. But this is a little bit different. Why? I have these 3 p's. So when I pick a p, I don't know which one it is. So I have to account for that. I have to divide by those repetitions. Okay, so I will let you tell me what that equals.
I have a calculator.
Yes, you may. Sorry.
It's okay. I forgot.
Oh, Courtney did that. Oh.
She included that.
She was standing in front. She went down the line.
Yeah.
And stood in front of it.
Apparently the battery is from like 2012, so.
Okay, so how many arrangements can I make?
840.
Okay. What if I start with a P? So if I start with a P, what do I have left? I have O-P-P-I-E-S. So what would that look like? How many choices do I have for the first slot?
6,
Then?
5, 3, 2, 1.
So that would be 6 factorial. Do I have any repetitions I have to think about?
2 P's.
I still have the 2 P's. I don't need to worry about that first P out in the front because I've basically designated it. I'm taking it a P and I'm putting it there, and then I'm just worrying about the rest of them. So what do I get?
360.
What if I make the first 2 letters both P's? So I take the two of the P's out, and now I have O-P-I-E-S. So if I take these 2 out, I don't worry about them anymore. They're gone. Or I think of them as just being ones. So I have these 5 remaining. No repetitions. What does that equal? 120. Okay. Question D says if all the P's are together. So I have P's as a unit. And then the O-I-E-S. Do the P's belong at the front Does it say where the P's go?
Devin, did you know there's a body director?
Or does it just say they have to be together?
They just have to be together.
They just have to be together, so they could be in any one of these 4 spots. So count this as being a slot of its own. The 3 P's are 1 slot. So then I have 1, 2, 3, 4. I still have 5 slots. It's just the 3 P's are one of those slots. So I would have 120 different arrangements where all 3 P's were put together. And question E is if the first letter is a P and the next one is not. So I have a P and then not a P, and then I have the next would be 5 after that, right? 2, 3, 4, 5. How many not P's do I have?
4.
Pardon?
4.
4. So I have 4 selections for there. And then in here, how many slots do I have to fill? 5. And of those 5 slots, how many P's do I still have? I still have 2 of them. And those 2 could be anywhere. I'm just going to put them in the first 2 just as a reminder that I still have 2 P's in those slots. So then I have to divide by that 2 factorial. So you know 5 factorial is 120. Divided by 2 is times 4, 240. So I would have 240 combinations that start with a P and then the next one's not a P. There's a class that has 5 girls and 7 boys. And we're going to form a committee that has to have 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee. Does order matter? So what does this make? This is a combination. Order is not important if there are no restrictions. So I'm picking 2 girls out of 5 and choosing 3 boys out of 7. So 350 committees can be formed. Okay? What happens if Johnny, who's the principal's son, has to be on the committee? So I have to have Johnny, and then I have to have 2 girls, and how many boys? 2 more boys. So the only one way to pick Johnny, I still have the 5C2 for the girls, but what do I have for the boys now? 6C2. Good. Okay. And then how many committees where Peter and Paul, who are twins, can't both be on the same committee? So that means the number of committees with Peter only, or Paul only, or neither. So the Peter only and the Paul only is kind of the same as choosing Johnny. So I still have my girls, and I have Peter, so I'll put the one out in the front for Peter. And then I have, actually no, it's not quite the same. It wouldn't be 6C2, it would be 5C2, because I wouldn't be able to include Paul. So this would be including the 5 other boys, because Peter and Paul make the other 2 to make maybe 7 boys, but I can't choose Paul in this one. And then I have or, which is adding. And then the Paul only would be 5C2 and 5C2. And then the neither, 5C2 for my girls. What would I have for the boys? 5C3. And 5C3 is the same as 5C2. So what's 5C2? So 10 times 10. How many committees? 300. I could do this as a complement question as well. What I could look is I could look at the number of committees with no restrictions minus the number with both. How many committees do both of them have to be on? So no restrictions would be taking that 350 from the first one, the 5C2, so the 2 girls and the 3 boys, and then the 2 girls. And with both of them means that I take Peter, I take Paul, and then I take 1 out of the remaining 5. So this is 350 from the first one. I know from before that this is 10, and 5C1 is 5. So that would be 50, and I still get 300. So I could look at it as one of 2 ways. Okay. This one's a tricky one because there's a lot of stuff going on in this question. A school band have practiced 5 popular and 6 classical musical compositions. For a school concert, they're going to choose a program that has 3 popular and 2 classical. If the order of the composition matters, determine the number of different programs which can be presented. The students' answers are shown below. Each student was convinced that they were correct, and they asked the teacher to check the work. Teachers asked them to write their answers on the board, and then they discussed the merits of each answer. So if we look at David's, did David consider order with his 11P5? Yeah, order matters. That's why he used a permutation. Did he do it correctly, though? What is he picking?
He's picking 5 out of the 11, so he's not making sure that he has 3 popular, 2 classical.
Right.
His way could end up with 5 popular songs and no classical.
So he does not consider the number, or sorry, the type of composition, I guess, would be the best. He's just picking any 5 out of those 11. Okay, what does Stephen do? Does Stephen consider order? Yeah? Okay. Does Stephen take into consideration the classical and the popular? Yeah, so he's got that part right. Did Stephen make a mistake? What is he starting off with? What does 5P3 represent?
The popular, isn't it?
Yeah. So his is popular and then classical. So he's only allowed the popular first and then the classical. He doesn't allow it to be mixed up. So the 3 popular songs come first and the 2 classical songs come last. Okay, so what about Helen?
She didn't consider order.
Yeah. So she considers the number of selections possible, but they're not arranged in order. So this right here, this is picking any 3 of the 5. And we're not concerned when we're picking the 3, let's say my popular music, I pick song A and song D and song E. It doesn't matter how I picked the 3 songs, I still have them. Whereas with Stephen, I picked song A first, no matter what. Then I pick song D next, no matter what. So Helen's allows for that movability. I can put song D ahead of song E or ahead of song A. So question B says all 3 students were wrong. How would I do this correctly? So to do this correctly, we actually start off with what Helen did. Her 5C3 and her 6C2 allow for the popular, so this selects 3 popular, and this is to select 2 classical. Then I'm going to arrange the order, because it's that order that is important. So how many songs am I playing? 5. So how many choices do I have for the first song? I have 5 songs, 5 choices. The second slot I have, then,
3, 2,
so how can I abbreviate that?
5.
So that 5 factorial takes care of arranging the 5 songs. The 5C3 and the 6C2 take care of pulling the songs out. What do you get?
18,000.
18,000 programs can be created where the order is actually important. And then from there, if I wanted to put more specific, then I could. So I want you to work on questions 7 to 20. They're all the numerical and the multiple choice questions.